This is section 3.5 in Algebra 1, and it's about point-slope equation of a line. So far, we've talked about the slope-intercept form of a line. And remember, slope-intercept is y equals mx plus b. And we talked about how the significance of slope-intercept is such that if it's in this form, then the m is the slope, right? And the b is the y-intercept. And the good thing about this particular equation and what we used it for all the time is that if we wanted to graph, so it's used for graphing lines, okay? But now we're going to move on from graphing lines into something else. Now we're going to talk about writing equations of lines. So in that situation, we have a new form of a line called point slope, all right? So point slope is used for writing equations. Okay, it's for writing equations of lines. Point slope looks like this. You have y minus y1 equals mx minus x1. So on point slope, again, the m means the same thing. The m number right here is the slope. So slope is always involved. But on this one, what you have, notice, is this x1 and y1. And all that means is it's the x and the y coordinates of a specific point. So it's like some number, comma, I guess I should say x1, comma, y1. So that just represents some ordered pair. For all we know, it might be like the ordered pair, 2, 3, or something like that. Okay? And then the x and the y that are in the equation, those stay the variables, because when we have equations of lines, don't we normally have an x and a y in the equation? Okay, so let's come down here to our first example. It says write the equation of a line. Okay, since it says write the equation of a line, it doesn't say to graph a line. It says write the equation of a line. That means my go-to is going to be point slope form. Okay, and so what you'll hear me say quite a bit is there are two things you need to write the equation of a line. You need a point and you need a slope, right? Because that way you can use the point slope. Right, in this case, do I have a point? Yep, I've got the -1, 6. So that's my x1, y1. And do I have the slope? Yep, slope is 4. So that's my m. So I'm going to rewrite this equation up here, but in place of the x1, the y1, and the m, I'm going to fill in these numbers. So I'm going to start with y minus, because that's what I have in the equation. Now in place of y1, I'm going to put 6. Equals, now I need the m, the slope is 4, and then in parentheses we're going to put x minus, and then remember the x1 is the x coordinate of that point, so it's going to be x minus -1. Okay, so that's the equation of my line. And hopefully all of you guys are noticing that we can kind of clean up that minus and negative, so I'm going to have y minus 6 equals 4. Really, this is going to become x plus 1. Now, that is the equation of a line, and I could leave it like that, but all the lines that we worked with before, didn't we, put them into mx plus b form? Didn't we end up solving for y? So let's just practice doing that. So let's take what we have here and solve for y. So I'm going to distribute the 4 on the right side. So y minus 6 equals 4x plus 4. And then there's really only one more thing I need to do if I want to solve for y. Wouldn't I just add 6 to the other side? So if I add that 6, I'm going to have y equals 4x, and since I'm adding 6, it's going to be plus 10. So this is the equation of the line that they're talking about. Okay, my box got kind of small there. This is the equation of a line that they're talking about that would pass through that point -1, 6 and have a slope of 4. Okay, so let's look at number 2. Write the equation of a line. So that means my go-to is point slope. So I need a point and I need a slope. So this is kind of like my checklist. Do I have a point? Well, yeah, I have 2 points, actually. So does it matter which one I call the x1, y1? Not at all. It doesn't matter. So I'm going to call this one here my x1, y1. Do I have a slope? Well, they don't explicitly give me the slope, but I can find the slope, right? Can't I find the slope by, subtracting the y's on top and subtracting the x's on the bottom? So let's go over here to the side and see if we can find the slope. So the slope is subtract the y's on top, 10 minus negative 2, subtract the x's on bottom, 2 minus 5. So my slope comes out to be 12 over negative 3. And doesn't that simplify? I think that simplifies to be negative 4. Okay, so now I have point. You know what I just noticed? When I said we're going to call this point x1, y1, I actually wrote y2. I don't know why I did that. This is my x1, y1. Because it doesn't really matter how I label it, but... Okay, so now I'm going to fill into my equation. I'm going to say y minus, I'm filling into my point slope up here, remember? Y minus, what is y1? Well, negative 2 equals, what's my slope? Negative 4. Then I have x minus, remember x1 is 5. Okay, so there's my equation. But like I said above, I don't really want to leave it that way. I want to go ahead and solve for y. So I'll distribute my negative 4. So y plus 2 equals negative 4x plus 20. And then last step is add that 2. I'm sorry, subtract that 2. So y equals negative 4x plus 18. And that is the equation of the line that they were asking about that goes through those 2 points. Okay? So remember, if I'm writing the equation of a line, my go-to is to think point slope. All right, so when I look at number 3, it says write the equation of a line. Okay, so I'm thinking point slope on the graph below. Well, we've done some of this. In fact, on the quiz, I feel like we had some of these where we looked at the equation of a line and we were supposed to, we looked at the graph of a line and we were supposed to write the equation, but we only did them when we knew the exact y-intercept. And if you look at this graph, I don't know that exact y-intercept. I could estimate it, it'd be like 3/4, but we don't want to estimate, we want exact. So that's why we're going to use point slope. So in other words, I need a point and I need a slope. Well, I see 2 specific points identified, right? I'll just pick either one of them, it doesn't matter. So let's say I pick this one. So this is the point 2, 0. All right, so that's my point. And do I have a slope? Well, remember we said you can look at the slope of a line. You start at the left side, and what's it going to take to move over to the right point? Well, I'm going to go down 1, and then over 1, 2, 3. So the slope of this line is negative 1 because I went down, and over 3. All right, so I'm going to use my x1, y1 right here, and my slope, and I'll write the equation. So it's going to be y minus y1 is 0 equals, slope is negative 1/3, and then x minus, the x1 is 2. And so again, we said, there's my equation, but if I really want to make it look like mx plus b, I would solve for y, so I don't really need that minus 0. So y equals, let's just go ahead and distribute, negative 1/3 times x, and then negative 1/3 times negative 2 is going to be positive. Think of this as 2 over 1. Don't you just multiply straight across? So isn't 1/3 times 2 just going to be 2/3? So that is the equation of that line. So remember how I said, hey, we don't want to estimate the y-intercept, and I said, I might be able to estimate it as 3/4. Well, actually, based on looking at this mx plus b, can't we tell that the actual y-intercept is 2/3? So if we had estimated it to be 3/4, we would have been wrong. Okay, look at number 4. Write the equation of a line that passes through the points, and then they give me these 2 points. It seems like this is just like what we did up here on number 2, doesn't it? Write the equation of a line. All right, so maybe this might be a good one for you to practice, and I'll get you started and see if you can, finish it up. So remember, I want a point and a slope, And then I'm going to fill into my point slope. So it might be smart for you to pause, try it yourself, and then see if we agree. So I've got it started. I found my slope. I chose the first point as my x1, y1. I plugged it into my point slope form. And I did want to mention to you on something like this. When you go to solve for y, you're going to have this crazy fraction. I'm going to distribute that negative 2/11ths. So y minus 2 equals negative 2/11ths x. And when I distribute it to the 1, it's going to be a negative 2/11ths. And now on this next step, if I'm going to solve for y, I'm going to have to add 2, right? So if I add 2, I'm going to get y equals negative 2/11ths x, and I'm adding 2 to this 2/11ths, trying to figure out what that is. I mean, it's possible that we could do a common denominator and put it together and all, but on something like this, especially if you're just doing your homework, I'm fine if you want to use your calculator and figure out what negative 2/11ths plus 22 is. I think it'll come out to be, let's see, positive, I think it'll be 20/11ths. Okay, so there's the equation of my line. All right, so now look at number 5. Now again, doesn't number 5 look just like we did up here for number 3, except I want to point something out. On number 5, do I have to use point slope? And the answer is no, I don't have to, because do you notice on number 5, I do know what the y-intercept is. I can tell that the y-intercept, which is the b, is exactly negative 2. I'm not estimating, it is negative 2. And I can look at this line and I can tell for sure that the slope is, let's see, up 1, 2, 3, and over 1. So I know that the slope is exactly 3. So this is like the ones on the last quiz. I don't need point slope. I can just go straight to y equals mx plus b. So y equals mx plus b. So if you know the y-intercept, the exact y-intercept and not estimating it, great, you can go straight to mx plus b. It's just that that's not going to be very common. And so that's why if you don't know it, you got to do your point slope. Okay. Okay, so look at number 6. It says, write the equation of a line. So my first thought is point slope that passes through the point. Okay, that's good. There's my point, right? My x1, y1, and is parallel to this. Okay. Well, remember, we need a point and a slope, right? And we have the point. So how am I supposed to use this equation to find my slope? Well, it says that I want a line that is parallel to this line. Well, doesn't this line have a slope of negative 4? And if I want a parallel line, wouldn't the slope of the parallel line also be negative 4? So I can still use negative 4. I'm just going to use this x1, y1 that they gave me. So I'm going to say y minus y1 equals slope times x minus negative 2. And then I'm ready to change it to mx plus b. And now that we've done this several times, let's see how good you guys are. Let's see if we can do it all in one step. So here's what I'm thinking. When I distribute the negative 4, I'm going to have negative 4x. And then when I distribute the negative 4, I would have a negative 8. But then when I bring over the plus 3, won't that be negative 5? If you need to write in the step, that's perfectly fine. I just saw that I was running out of space. Okay? And then look at letter B. So letter B is a whole different question as far as now they're saying I want an equation of a line. They're still, the way it's worded, I want the equation of a line. I still want it to go through that point. So that's still my x1, y1. But this time I don't want parallel, I want perpendicular. Like we said, this line has a slope of negative 4. So wouldn't the perpendicular slope be the opposite reciprocal? So the perpendicular slope would be positive 1/4. So I can write my equation. I can say y minus, remember y1 was 3, equals my slope of 1/4, and then x minus negative 2. So there's my equation set up. I'm going to distribute. So y minus 3 equals 1/4 x plus, think of this as like a 2 over 1. So when you distribute 1/4 times 2, isn't that going to be 2 over 4 or 1/2? Last step is add my 3, so y equals 1/4 x. And if you're adding 3, and you can easily tell, hey, 1/2 plus 3 is 3.5, that's fine. It's just that I don't want us to get in the habit of using decimals all the time instead of fractions. All right, so number 7 is just another example of what we just did. Okay, I don't think we need another example of what we just did. All right, so now let's look at some special cases. So look at number 8. It says write the equation of a line. So it looks just like what we did earlier. So I'm thinking point slope that passes through these points. Okay, so let's think. I know I need a point. I know I need a slope. All right, I've got a point. I could, choose either one. It doesn't matter. And then what I have to do, I need to start with my slope. So if I start finding my slope, I'm going to say m equals, on the top, I'm going to have -2 minus 8. On the bottom, I'm going to have 3 minus 3. And do you see this is going to come out to be -10 over 0? That doesn't equal -10, and that doesn't equal 0. Remember, if there's a 0 on the bottom, it's undefined. Okay, so now we're stuck, because I can't put undefined into my point slope. I would never do that. So now this is what makes it a special case. So let's think about it. Didn't we talk about some certain lines that have a slope that's undefined? In fact, do you remember what kind of lines have a slope that's undefined? Hopefully you remember that it was vertical. Remember we said if the slope is undefined, we know it's a vertical line. And what does the equation of a vertical line always look like? It's not y equals mx plus b. Remember, aren't there only x's? A vertical line is always going to be x equals some number. So in this case, it doesn't matter which point you look at, what does x equal? X equals 3. So the equation of the line is x equals 3. All right, so look at number 9. Write the equation of a line that passes through these points. Again, you start off with the same thing. You're like, hey, I've got my point. I need to find my slope. And when you start finding your slope, you're going to do on top -2 minus -2. On the bottom, 5 minus 3. And doesn't this come out to be 0 over 2? Is that undefined? No. If the 0 is on top, it equals 0. So again, isn't that one of those special cases? What kind of line always has a slope of 0? Wasn't that the horizontal lines? Horizontal lines. And the equation of a horizontal line, remember, that one wasn't y equals mx plus b either. Weren't those always just y equals some number? So in this case, it doesn't matter which point you look at, doesn't y always equal -2? So the equation of the line is y equals -2. And I think what we need to do here is make ourselves kind of a little, you know how anytime in notes you have a box, you know it's going to be important? So let's look at this a second. Let me kind of make this a little bit smaller for just a minute. Okay. Let's put here. So anytime I know we have horizontal lines, right? I know the slope is 0, and the equation is y equals some number. Okay. Look, I'm making a box. Boxes mean important, right? All right, and anytime I have a vertical line, I know the slope is undefined, and I know the equation is always x equals some number. Now, I don't know if this helps you. I had a student one time tell me the way they remember this is using this weird phrase. They will say H-O-Y, hoy. They say hoy, H-O-Y, horizontal 0, y, horizontal 0, y. And then for the vertical, they will say V-U-X, V-U-X. And so they say the phrase hoy vux, hoy vux. I know it sounds stupid, but it has always made me remember, and a lot of times when I tell students, they seem to find it easy to remember this way. That's how you know which one, horizontal or vertical, has 0 versus which one is undefined, and which one has the equation y equals a number versus which one has the equation x equals a number. Okay, so keep that in mind. So look at number 10. Write the equation of a line that has an, you know what, I want to come back to number 10. Let's go to number 11. Sorry about that. So number 11, it says write the equation of a line that passes through the point 4, 5. So I'm thinking, okay, point slope. I've got my x1, y1, but then it says, and is parallel to the x-axis. So in order to know the slope, I need to think about what this looks like. So I suggest you kind of think about, draw a line, a xy axis. If I have a line that is parallel to the x-axis, wouldn't it be going this direction if it's parallel to the x-axis? And if it's going that direction, what kind of line is that? Hey, doesn't this have to be a horizontal line? And if it's, look at your Hoy-Vux, and if it's a horizontal line, what do we automatically know the equation is? Look right here, horizontal, isn't it? Y equals. So the equation of this line is y equals something. Well, what does y equal? Well, you've got the point 4, 5. The y is 5. That is the equation of the line. Don't say 0. The slope is 0, but that wasn't the question. The question was, what's the equation of the line? If they had said, what's the slope, you would say the slope is 0. But that was not the question. Okay? Look at number 12. Write the equation of a line that passes through the point 4, 5, and this time it says, and is perpendicular to the x-axis. So again, think about the picture. There's your x and your y. If I draw a line that is perpendicular to the x-axis, doesn't it have to be going this direction? Right? So doesn't that tell me, oh, this has to be a vertical line? And if I want the equation of a vertical line, isn't it always x equals some number? Well, in this case, what does x equal? Well, look at your point. X equals 4. So the equation is x equals 4. If they had said, what's the slope, I would have said undefined. But that's not what they asked. They asked me for the equation of the line. Okay, look at number 13. Write the equation of a line that passes through this point and is parallel to the y-axis. Again, draw a picture. There's x, there's y. If it's parallel to the y-axis, isn't it going this direction? Oh, it's vertical. And if it's vertical, it's got to be x equals, what does x equal? 4. Okay? So yes, these are the special cases. But if you have it straight, if you have that Hoy-Vux straight, these are pretty easy problems. So look at number 14, right? The equation of a line that passes through the point and is perpendicular to the y-axis. Now, I'm drawing this out every time. You know, you don't have to draw it out. If I'm you, I'm just picturing it in my head. If I have a line that's perpendicular to the y-axis, doesn't it have to be going this direction? Oh, it's a horizontal line. That means the equation is y equals some number, and in this case, y equals 5. Okay. So now I want to go back to number 10. I wanted to skip it because I wanted to do all the ones that were kind of similar, you know, using that little chart. But now let's go back to number 10. It says, write the equation of a line. And so as soon as I see that phrase, my first thought is point slope, unless I decide that it's one of my special cases. I know it has an x-intercept of 5, not a y-intercept. Well, if it has an x-intercept of 5, all that's telling me is that it has an ordered pair 5, 0. That's what that means, right? X-intercept of 5. And it also passes through the point 2, 3. Well, this is just like the problem that we did, where was it? Up like number 4, right? Where you're given 2 points. So let's just see. I need a point and a slope. Got a point. What's my slope? Oh, subtract my y's on top. Subtract my x's on bottom. And I think that's going to come out to be, what? 3 over negative 3, which simplifies to be negative 1. Okay, so to write my equation, it doesn't matter which point you pick, whether you pick the 5, 0 or the 2, 3. So I'll pick this one. That's my x1 and my y1. Then I'm going to plug into my point slope. So let's see, I want y minus y1. So y minus 0 equals, m is negative 1. And now I want x minus x1. So x minus 5. Okay, so I've got it set up. I just need to clean it up, solve for y. So y equals, distribute the negative 1, negative x plus 5. And that is the equation of the line. Okay, so hope these notes help with section 3.5.